Hi, Juan. Welcome back.
Hi, Adam. Nice to have to be here again.
Yeah, and
your
Juan
podcast.
is pronounced correctly?
Yes, it's correct. Juan. Yes, Spanish
Juan.
name. Yes.
Very good. You were at Devox, right?
No, I wasn't at Devox. My colleague was at Devox. Thanos. Yes.
And how was the experience he reported?
He told me it was amazing. I think it was his first talk in a big audience, so he was like overwhelmed with all lighting, people, etc. But he told me it was a really good experience. Yeah, I was at Devox once, but it was online. It was Devox Ukraine, and we had, because of COVID, we had it online. I couldn't travel, and that was 1 year, I think, before the war.
And how was the feedback to Tornado? So was there any feedback or?
Yeah, so people tend to like Tornado. They like the idea. I think it's very, I don't know how to describe it. Maybe esoteric. I don't know if that's the right word to describe it, but something like, that's cool. That I can do that with Java. I didn't know that has the potential to do that. And I think people appreciate that, which is really good. But what the main criticism is to find the right use cases. And we're actually doing this right now.
Okay. So we had already a chat, I think, in the summer. And there's also Project Babylon on the horizon, which is very also similar, is somehow related to Tornado. And maybe we should know, so what Tornado is. Tornado is the attempt to run Java programs on GPU. Or not the attempt, it is actually, or even not even GPU. You could run, GPU software on CPU even. So this is like abstraction between CPU and GPU, right? So this would be the rough description.
Yes, that's correct. So Tornado is actually a bigger umbrella. So we focus on the GPU because it's an easy device. Many people have GPUs sit around. So either you have the integrated GPU. Many CPUs have this one. For example, Intel i series, for example, i5, i7, i9 series, they have the Intel integrated GPU. And it's very powerful for many things. Plus, many people might have a discrete GPU, like an NVIDIA GPU, etc. So we focus on that because for data power applications, you can get good speed ups with low effort, I would say, from the compiler runtime side. However, Tornado has more things. As you mentioned, Tornado can run also on CPUs, and when running on CPUs, it's using all cores available by default. So it's parallelizable from the beginning, using all cores and even vector instructions, but can be used also for FPGAs, or we're using now in another project we're working on for running on RISC-V with vector instructions, which is very appealing now.
RISC-V is the open source ARM platform, right?
Yes, open source hardware platform. I think people try to decouple from ARM, yeah.
Interesting, because this is also what Sun did at the end, right? So they had also open source CPUs, and now there's maybe some legacy of Sun is living within ARM5.
Yeah, there's a big effort to get RISC-V, a real platform to run. We are working on this project to try to run a software stack. Many companies are involved. For example, KTM, the motorbike company, is involved, bringing some use cases. Red Hat is involved, try to get Quarkus running on these processors, as well as we have other use cases. I think we talked about that the last podcast. This company from the European Space Agency, Gaia, so they want to explore also that those accelerators with RISC-V. The thing about this, you can have attached accelerators to this platform, for example, a powerful GPU or any other type of accelerators. So that's very appealing for many people now.
Can you we should recap, because summer was like, I don't know, 100 episodes ago at least, or 200 maybe. So can you just, write your regular Java program, then launch on Tornado, and something will happen? Or how to, think about that? So how to use Tornado?
Yeah, that's a great question. So the way it works is that Tornado tackle data parallel programs, let's say. The thing is, it happens that we can write those data parallel programs in Java. So for that, the developer needs to do some rewriting of the code. We have types, new data types. We didn't have those data types. We can discuss that later, why we introduce it. But basically, we have a set of new types: float array, double array, these kind of things, plus vector types, and an API to identify the methods to offload, essentially. That API, we call it task graph. Basically, we can compose graph of many methods. Each of the methods, well, Tornado will do, the Tornado runtime actually will do, is to offload each of the methods to the target accelerator. For example, a GPU, an FPGA, a multi-core, even many of them at once. It's also possible.
So
yeah, go ahead.
So my understanding is you have to write a special program which will going to represent or being translated into an execution model, and this execution model is going to be executed on GPUs, CPUs, or of FPGAs or whatever. There's an abstraction layer then.
That's close. Yes, that's the intention. So I should mention that the way we interact with Tornado is that usually we tackle loops because that's the most time consuming, and we annotate sequential programs. So let's say you have a for loop. Let's keep it simple. You have a vector addition. You want to add two vectors because the vector addition, each of the items or each of the iterations don't correlate with each other. So I don't need to wait.
And vector is a list in Java, right? Would be.
Yes, but we provide a vector data structure, if you like. We don't have proper object support on the GPU. We provide our own that can map to those data structures.
But is the vector like the geometrical vector, or is the vector more like the list in Java, similar to this in Java?
The geometrical one, yes.
Okay.
Yes. Basically a collection of numbers. Yes, you can see it as a collection of numbers, but we don't need the headers for each item, if you like, that correspond with the actual collection in Java. So that's one thing. And then using annotating these parallel loops, sequential loops, but we annotate with an annotation with add parallel annotation. Then the Tornado should be able to identify, okay, this method needs to be, offloaded. I compose in a task graph. The user told me where's the annotation, and then the compiler will do the transformation that are required to transform a sequential to parallel and run it. That's the intention.
So what I understood, you have almost regular for loop. So is it a regular for loop, or is it specific?
No, regular for loops.
Regular for loop. I can annotate the for loop with at parallel, and then this is like a hint to the compiler plugin, right? Because it has like a micronode, so it finds parallel and does something with it. And you have to use a specific types for optimizations. This is close to collections in Java. It's a collection in Java, but optimized one, because you said you don't need headers. It's just a raw type or something.
Exactly.
And then the regular Java C compiler compiles the entire thing, or is it or not? So I mean, there is an intermediate step where almost like a code generation. If you find the parallel, then the compiler plugin. There's a specific name in Java. I forgot the name. What is the name? If the compiler reacts to annotations, there's in Java SE, there's an API for it, right?
Well, we use the ASM library to inspect these annotations.
ASM. Okay. You use ASM. The ASM.
Yes.
This is a very popular one, by the way. Everyone uses
I think so. Yeah. We use that one. Yes.
So,
yeah, right. So there is a compiler underneath. The compiler is Tornado compiler. So the Tornado compiler is an extension of the Graal compiler. We took the Graal JIT compiler, and instead of going to CPU backend, we extend with a GPU FPGA backend. Essentially, Graal gives us a very nice API to build a graph form from the bytecode format. So everything happens in runtime as well as Graal. And then from the graph, we do transformations. For example, if we say, this loop is parallel, we see a node for the for loop in that graph. And then we replace that node with a parallel for loop. And then we do a bunch of optimization. We have quite a lot, actually, because we interleave Tornado optimizations with Graal optimization for Java. We make use of, we don't reinvent the wheel, essentially. For example, for inlining, we reuse it quite likely from the Graal compiler, constant propagation, we use it from the Graal compiler, etc. We tune some of them. For example, in the case of loop unrolling, actually, we tune it for the FPGAs to increase performance. But then at the end of this process, we have a graph that is closed up in semantics of the actual parallel programming model that sits underneath. Could be CUDA, could be OpenCL, could be SPV, right? Those are the programming models that the GPU understands. or any accelerator, compatible accelerator understands. And from there, we do the code gen. So from the graph down to the actual OpenCL code, from the graph to the NVIDIA PTX code, and so on.
What reminds me, what you are explaining is very similar to Project Babylon. So we had a chat about Project Babylon with Paul Sanders, and what they have, the ASM part is very similar to code reflections, where you can generate almost Java code with a pseudo language. Then they have also a kind of an execution model, where is later a visitor pattern is traversing this and generating various code, and there's also the intention is to run on GPU. So this is it seems like the Tornado is almost the implementation of Babylon idea, right?
That could be one way to see this. I think it's inspired. Yes, I have talking to Paul and Gary for many years already, actually. So to me, I see the Babylon project as an approach to get GPU or any other code. Actually, it doesn't have to be GPU code; it could be anything. It's any code transformation, but higher level up in the hierarchy in the software stack. So just to to put this on the table, like Tornado run or generates code from Java bytecode. Because of that, you have to implement some sort of tricks. For example, we mentioned the ACM library, which is not Java standard, but I mean kind of standard de facto because many people use it. These kind of things. While Babylon, you shouldn't use any of this because Babylon itself can give you all this information very high level in the software stack, very close to source. That's the main difference that I see in these two. Plus, the Babylon at very beginning, at least for now, based on my understanding, will focus. It will drive the API development based on, for example, the GPU use case, but it doesn't bring a GPU programming model. It will be inspired by a GPU programming model, potential one for Java, but it doesn't bring that. Right? And in that case, we only be pure code generation. But Tornado is more than just code generation, just to make the differences more clear, perhaps. Because code gen is one thing, and then there is also data manipulation, data handling, code handling, etc. for the whole Java program that interacts with the GPU. And that's also part of the Tornado, but it's not part of Babylon as far as I understand.
So what means is the Babylon is a high level because they have a framework to declare a meta model in the translation almost, and you are operating on bytecode level. So what could even happen is that the model from Babylon gets translated to Babylon code with your annotations, and then you take over the optimization, right? This could be also one path.
Exactly. We are discussing with Paul and Gary exactly to jump in this section. Yes.
But this is great news, because what this means that the translation from Babylon to Tornado would be really maintainable, because your annotations are understandable right now, right? Because you can write the code and we get a highly optimized pipeline.
Yes, that's one thing. The other thing we think, but this is more like an idea, perhaps, not just, I mean, we need to sit down properly and design this. This is kind of the idea floating around based on conversation I had with Gary and Paul. So essentially, we could go perhaps step further. And right now in Tornado, the developer needs to do some rewriting, as we discussed earlier. But what if we take Babylon to not do its on the code rewriting and use the GPU directly from a model in the code reflection API? That could be the really nice step, because that will mean that for some workloads, I'm not claiming that could work for everything. I think it's complicated, but for some workloads, that's very appealing, because let's say, Java platform can identify that could be done or could be accelerated on a specific GPU and a specific hardware. And the tooling behind can say, I know how to do it without you to interact. And you get benefits in performance.
Yeah, but for me, I already had the idea, this realization during a chat with Paul in the recent podcast, is that for me, this almost like what the hotspot is doing anyway, right? Because the hotspot constantly is optimizing specific methods, and this is just higher level. So the hotspot has to, in a future hotspot, hotspot V2, maybe should be able to recognize, hey, this thing is not meant to run on CPU. Maybe I optimize for GPU, right? So I mean, it sounds easy, but it's hard to implement. But it's from the conceptual level, this could work.
Indeed, this is a hard problem, and that's why we're trying in research to do for the last, I don't know, decades. I would say 2-3 decades. Yes, that's a panacea, right? So you have something that you don't know where to run it, was more efficiently, and you're able to identify clearly which device is the best one and with which parameters. Yeah.
And have you a major release of Tornado recently, or is it just?
Yes, so we did a release end of the last month, end of December. We call it TornadoVM 1.0. It was a big jump for us. There was a lot of thinking, a lot of development in there. And yes, that's we continue. I mean, it's very active now. We are planning a new release these days, in this week. Again, it's going to be a minor release based on this one, but it's kind of incremental. We're going to push the number of releases now. And yes, we want to increase activity in Tornado side.
So this was the 1.0 release in December. Huge news, right?
Yes, correct. That was the 1.0. We tried to... Well, it was a big jump, so we were discussing how to name it. Some part of the team say, well, it's a very big jump, so let's call it 1.0. Okay, let's go for it.
Why is the jump that big? So what was the biggest change?
Well, we adapt. We have changes in the API, first of all. Those changes in the API, to me, doesn't justify big version, but the main difference is that we transition from on-heap data to off-heap data. So we provide new types, and that's how it's linked with the conversation we had before. So before 1.0, you could use any Java array primitive, like int array, float array, all of these. And that worked really, really well. The issue is that, we have issues with the garbage collector, potentially issues with the garbage collector. And this is not just for Tornado. Any project that does this, Aparabi has the same issue. If you remember Aparabi by AMD a few years ago, they have the same thing. So how to avoid the GC, how to avoid having problems with the GC is by locking the GC in some sections. Essentially, when you run GPU code, by default, all these runs are non-blocking. But what happened is that, what if the GC moves a pointer while you're still running on the GPU, and then you get a crash? So to avoid that, what we do, Tornado, Aparabi, all these projects, what we do is to lock the GC. That worked, but I mean, it's not the ideal solution. Plus, it prevents us from doing other optimization. For example, share memory, in which some of the data can be shared across GPU and CPU, for example. And this strategy wasn't allow us to do this, because still you need a copy from on heap to off heap and then do the computation. So we decided to transition everything to off heap using the Panama API. So right now, Tornado is a small rewrite at the user level, but it's a big change in the compiler and runtime level of Tornado. It's a really big change. So we have new types that represent basically, wherever you allocate an array, let's say float array or int array, are directly off heap. And that gives us more room for optimizations in future versions. And that's what we are working on. That's the main thing that we provide. Plus, we integrate with the latest JDK21, and we integrate with the latest Graal compiler. And that's a huge step because, sometimes with the Graal compiler, sometimes it's easy. Just, 2 days of work, that's fine. Because always we need to change something in the compiler, because they change some nodes, they change some packages, they change some functionality. But sometimes this is a big change. In fact, one of the latest one, it took us like 3 months to get there. The PR with, thousands and thousands of lines just to integrate with the latest Graal. Although we are in contact with the Graal team, but just it is what it is. So, and that's a huge effort from our side. So I'm happy that we manage and it's done, and we continue integration with them.
Interesting that you're using Panama already. So Panama is like the replacement of JNI, or the better JNI, right? So this is...
Yeah, so we We don't use the Panama Foreign Function API for now,
Okay.
although we are planning to do.
Mhm.
We tackle in this release the Panama Memory API, so of
Okay.
memory, of basically segments of heap.
Yeah, and off-heap is an interesting technology. I know it actually from databases. So if you work with databases back then, pure Java databases, and the enterprise releases often had the off-heap idea. And what off-heap means is that the memory is stored in memory map buffer back then, right? So and what memory map buffer is actually interesting data structure in Java. You write to a memory and this is offloaded by the operating system somewhere, right? This was back then. This was, I don't know whether it was created JDK 1.4. I think it was a long time ago.
You're referring to the direct buffer API?
Direct buffer, right?
Okay.
Direct buffer, and this was the memory map buffer was one implementation. You could write, the problem with that was, as I remember, you had to know in advance how much you need, and then you wrote bytes into this buffer, and it was automatically managed by the operating system, right? This was the off-heap buffer back then, the old one.
Yeah.
And you using the new Panama API for it, right? Not the direct buffer, rather than the Panama, right?
Exactly, that's correct. Yes. So the direct buffer has some limitation. I used that on a prototype that I did for my PhD. Was before Tornado. It was a different project based on same idea. I also use crawl, etc. And I directly use off-heap with direct buffer, but has some limitation. For example, if I remember correctly, you cannot use a buffer with more than 2 gigabytes. I don't know the technicalities for that. Should be something related to OS, perhaps, of the platform. But Panama can get around that. So you can have very large buffers if you want to. Plus, you have kind of safety even, because if you mess around with the pointer, you get still in the Java stack. And that's interesting.
And it was garbage collection issues, I remember, we had also with direct buffers, right? Because it is handled by the operating system. So there was some limitation as well. But Panama is nice, the API, memory API.
We really like it, yes. Yes.
How it looks like, roughly, you know it? So how to get something off-heap with Panama? So hello world off-heap?
Yeah, you create a segment, you create a memory segment, and you say off, auto, which they have the concept of arenas. Basically, it's a global arena with a global vision or share or etc. And then you define your space, your memory invites the space you want to allocate. For example, 100 megabytes of type integer, or you can just say I want this number of megabytes, whatever type it is. And you have flexibility. You can have, for example, in the case of Tornado, is nice because we still need some header information stored, but this is now handled by Tornado runtime. So what we do was reserve at the very beginning of the segment some space, some bytes. I think we have now 5 by default, something like this. By default, to store some meta information that we want for later use on the GPU, and then we can have the whole data, etc. It's very flexible. That's what I meant to say. It's very flexible.
This is the arenas. I think is the idea, right? That you can have on arena several segments, and there will be garbage collected all at once, right? This was the idea with arena. It's like a facade for the segments, right?
I think so. Yes. I mean, I'm not exactly into that. We use the general one from Panama.
And you also plan to use the foreign function API as well, right?
Yes, correct. We need to study first this because we have a lot of C++ code. And I have been talking to Mauricio, which is one of the main designers of this and architects of this API, Panama. And it seems like for C++ is kind of more difficult, but I think how we use it in Tornado it should be straightforward. So we need to do a kind of proof of concept first before we jump into that. But yes, it's in our plans to transition fully to Panama.
I had a recent conversation about eBPF with Mr. Bechberger, and he just created with JExtract the reverse, engineered from C to Java. So he was able to talk to Linux eBPF with Panama. So, but you could try similar things, right? If you have already C++ code, you could use JExtract, generate Java code and see what happens, whether it will fit your old model. So you will need maybe an abstraction layer, but it could maybe work.
I believe so. Yes. I haven't tried, to be honest. So I'm
yeah. So I would start with JExtract. So it seems promising, and then see what happens. So okay. So I think what also could be interesting. So I didn't knew that you are so high end. Java 21 and Panama is actually more fun than I thought. The conversation with you. Then what's also interesting in longer term is maybe Project Valhalla with the value types, right? Because you mentioned the collection of data types without a header. So maybe Valhalla could help you, right? Later.
Definitely. Yes. So that's one of the points that I believe Babylon should tackle. The definition of standardized types for accelerators. I kind of pitched this idea. I gave a talk at JVMLS last year, and I kind of pitched, this topic because we need them. I'm looking for something like a representation of a tensor operation, a tensor data type, and the array as well, that are really related to deep learning domain, but also opens up new possibilities for new accelerators as well. And I think Valhalla will help. And I think there is another project from Oracle. Gary Frost gave a talk at JVMLS. It's what they call HAT, Heterogeneous Accelerator Toolkit. Mainly focused on GPU and uses core reflection API with a class file API with a new accelerator API. That accelerator API looks to me very similar to Tornado API, with some, cut downs in some sections that, we can argue about we did it or not, but yes, it looks to me very similar to that. It's kind of basically taking all of it, which is the reflection API, the class file API, the definition of an abstraction layer for new hardware, and the definition of types. And that includes, for example, ND arrays. And that's very appealing, using Panama. So it's kind of everything getting, it's kind of separate project, but if you put all of this together, you have a very, very powerful platform.
Yeah, indeed. And the funny thing is, so I'm mainly, business developer, I would say. So I spend my time in enterprise projects, and I took a look at the Valhalla, and I took a look at the others. Okay, what they are doing? They're playing with strange things. Maybe it just gets, 10 milliseconds faster, and I have problems, with something is 2 minutes too slow, not 10 milliseconds. So I have, because business project has complete different problems. And what I completely overlook, the GPU part is okay. The entire optimization and all the things are actually really interesting for low-level programming. And after 10 years, I think 10 years. I think it was first announced that the first Java ones 10 years ago. I remember, and at keynotes, the Project Valhalla, the Project Sumatra, I remember, and all the other projects. And now is the perfect storm, because now I think use cases, right? A use case I wanted to ask you. Are you aware of the Whisper model, for instance, from OpenAI?
No, I'm aware of this new programming framework or model called Tristan. I don't know if it's related.
Maybe. So what Whisper is, you can have translations, transcriptions. So the Whisper is able to transcribe MP3 to text.
Okay.
And so nothing new, or it is amazing, but I'm saying it just works. But it was written in Python and is slow, right? But what a guy did on GitHub, he rewrote parts of that to run on C++. And now it is 2 to 3 times faster than Python. And I wonder, you ask about the use case. Not only that. It is in C++, but he also created GNI API, so that with Java you can call the entire translation process. Where I'm going with it, I already have lots of requests from my clients, because the question, AI is nice and machine learning is nice, and then the models are also important. But the question is, we have enterprise applications, we have apps. How we integrate, the models, how to test them, CI/CD, everything. So everything is open. It's like the very beginning of Java. And so good, we could just try to run Python somewhere in the Docker and try to call it via REST, but this is a mess. This forget it, right? So the best optimization ever would be we have a Java native integration with the model. So just on Java method, we call it and call it done, right? And this is the future. So I think it's not only the use case. This is where the money is, because the large companies would like to have local models called locally and have not the same stability we had for years. Because so my common problems, in enterprise development were quite boring. We had, for instance, what I remember, year 2000, 2002, the main challenge in most of my projects were we had software written in C by actually identical to now, insurance company. Software written in C by mathematicians, and we had to call it from Java. But, we had memory issues, garbage collector didn't work, and concurrency didn't work at all. So we had to find out, can we call the method from 2 threads, from 1 thread? If not, we had to start the model in parallel. Does the model access a common data structure? So is it, re-entrant? And we spent half a year, just to optimize maybe 3 methods in Java, and at the end it worked. And for me, we get exactly the same problem with the entire AI as well, because we get a piece of code and no one knows the latency, how often we can call, is it re-entrant, idempotent, or how it works, right? And if you manage with Tornado or Babylon, to have a tight integration or run something locally, I think this is a huge use case.
I'm so happy you mentioned this. So I'm involved in a new startup now. And basically we're spinning out from the university, and that's exactly what we're doing now. So we're using Tornado as drivers to provide solutions for AI. I pitched this idea. This is public information. You can. I talk about this in JVMLS. I pitched this idea, and it's essentially how to enhance the Tornado APIs, the TornadoVM programming model, to accommodate AI workloads. And the key aspect for us is to still write Java code. So the user belief is still Java. And for most part of it, it is. However, the main thing is as follows. So just to give you a bit of background, we integrate
What's
Tornado.
the name of your startup, if you can mention this?
So yeah, of course. Paravox is called the name.
Paravox.
Paravox, yes.
So we should add it, to title at least, and and to the show notes as well. Paravox, okay?
Yeah, we're in the initial phases though. So, but yes, it's running. So the company set up, and yes. So what we did was to try Tornado with Llama. You know Llama, this model from Facebook, the LLM from Facebook. It's called Llama.
Yeah, Llama.
Llama, exactly. So we ported. We have one
with double L, and you can even run it locally. Actually, so
exactly. So we found a port from, this is a Java.c, okay, in C and C++. And one engineer from the Graal team, ported to Java in order to measure against the Graal compiler. And we took
Llama was ported to Java?
Yes.
Wow.
You can run Llama locally. I think it's a version, it's a trained to run what is called tiny stories. Basically, it's a model trained with less data, but it's as efficient as the big one.
No problem, but this is the beginning, right? with one engineer ported this, what will 2 engineers do, right? So, okay, very good.
The implementation was actually nice for us because kind of was directly to the point where I'm not interested in the model itself. I'm interested in how we can accelerate this.
Can I interrupt you briefly? But you have to explain your startup. But what interests me, how we can imagine the C++ code, in Llama. What is it? Is it like a thin framework over, I don't know, lots of parameters, or is it just a program which was compiled from something? Because I still have hard time to imagine what the Python guys are actually doing. So at the end, do they have a function which can be called with lots of parameters, and the parameters the model weight, which can be or you have a rough idea what you get from the Llama? So is it what is it? Is it
myself haven't played with the C version. I have played with the Java version, but essentially what it does, this one in this case, is to run the inference of that model. So you can run the inference locally if you want to. That's the purpose. So you have a piece of text and gives you another piece of text. So for example, tell me a joke, and then he will tell you a joke. That's the goal. And you can define the parameter for that inference. Right? You need to download the tokenizer, which is already built you download the model, which already built, and then you run the inference in your code. And that's what this does. And I'm pretty sure.
And what is the model? And the model, what is
Llama
exactly?
Llama is the model. Yeah.
Yeah, but what is inside? Is model the data? Are model the parameters, or you know what I mean? Because now you have Java, so it has to look. What is it in the model inside? Java calls the model. So what is called there?
So these models are based on transformers, right?
Yeah.
So
I know conceptually, but from software perspective, if you open it.
you have the model contains this training for all based on the tokenizers, all these parameters, all these combinations that you have.
Parameters. Exactly. This is parameters, and this is basic. This is numbers.
Yes.
Numbers encoded, base 64 encoded, or what is it?
I think they're encoded. Yes.
Oh, okay.
But this is
Okay, so model is then for Java developers like a serialized list or hash map, right? A huge list or hash map of numbers. This is the model, right?
It's a huge list of numbers, correct? Yes.
Yeah. Okay. Cool.
Yeah. And each number represents a kind of a token, encoded token, let's say.
And the Java part is able to understand the Llama model now, right?
Well, there standard utilities just load the tokenizer, load the model, and then just pass your text and give you the inference back. Yeah, that from that inference process gives you the text back. That's what.
Yeah, but if they put this to Java, then Java has to understand the serialized numbers.
Correct. Yes, correct.
This is what I meant. This is interesting me. What is because this is huge. Now Java can understand a Llama model and maybe other models as well. Because if you're done with it, I mean, Llama is a standardized. It's like, I forgot the format, but it's like standardized Onyx or whatever. They have a standardized format how the models are defined.
So not sure about the actual implementation details of this part, but yeah.
Yeah, very cool. So you did already tokenizer. You did tokenizer means this is what we pay for, right? Usually, this is the amount of tokens are sent back and forth, right? So you did this.
Yeah, in this case, the tokenizer was already built. We just took it, right?
Okay.
That piece of Java program already takes the tokenizer. I think it's built by one of the engineers that was on OpenAI for a tiny model. So we just download that. Yes. So that basically that piece of Java program doesn't do any of this. It's already built, right? The thing is, you can load in, you can create loading in your data structure. For example, you can have in your store in your vector API using the vector API from Panama, etc. All this, and then you start the processing. And the processing is actually pretty simple. It's a bunch of matrix vector multiplications to do this plus other operations. But the ones we are interested in is the most expensive one for Tornado. And those are matrix vector operations. So what we did was to port these operations in Tornado and see what we get, and compare with the fastest version that we can have with Java, multi-threaded, multi-core, vectorization, enable, etc.
So what I understood is someone in GraalVM cross transpiled almost to Java. Then we had a model. In the model there were some matrix multiplications, which are matrix operations, no multiplication, which are somehow expensive, and you try to implement that proof of concept. And if you find a matrix operation, you put the parallel, let's say for me, annotation on it, and see how Tornado can optimize it, right? So
that's correct. Yes. Yes. Yeah, we got some speed ups by running on the GPU. I think it's around 16%, 70%, something like this. We have my colleague did a blog post in detail about all of this with code, etc., with profiler enable, etc. So if you're interested, I can send you the
sure
link.
Yeah, we have to edit.
Yeah. But kind of that sets the baseline for us because there's plenty of room for optimizations, and that's why we're working on this startup.
Yeah, and I can tell you when it is really interesting, because 70% means potentially 70% of the costs a company can save if it runs in serverless. Because speed is usually directly related to money and also to energy consumption. If something is 70% faster, it also consumes 70% less memory power. This is what usually is. It's not directly related because maybe you run on more CPUs, whatever. You cannot tell it, but usually you pay for less, right? And I would say, yeah, this is actually a really interesting use case. What you are offering, because different angles, right? So the first one is the ability to integrate seamlessly with Java is huge. First one, because you can write with standard. Let's say I'm using Quarkus all the time, so I can use Quarkus, expose the model via REST, and I'm done. Right? I have all my monitoring. Everything is already solved, and I'm orders of magnitude faster, because let's say my Llama is working locally, right? And I already took a look at this, and it's okay. But how I would integrate this thing with Java is not that easy. Is it like do I fiddle with streams, or should I search for GNI? How to call it? What is it? But you offer this answer, which is huge already. And I assume you could even offer support or whatever to the companies, consulting or whatever you have, right? So if you have questions, we can help you. And you have a model we could integrate for you, right? So this could be also interesting.
Yeah, so what we do is to offer high-level connections with models, let's say. We'll start with Llama because that's a good use case for us to start with. Mm-hmm. But we plan to include other models in the future.
Mistral?
Yeah, I heard about the famous paper. Yes.
Yes. Also works perfectly. It's also like Llama. I tried that, and also similar story. So it's a European one. So it's could be really interesting for European companies, because it behaves like Llama. So I'm maybe even bit better, and it also runs locally. So it'll be the next use case, for Tornado AI.
Yes. So the way we plan to this in the future is that there are many, let's say, I'm going to call it kernels, but understand in a way that those kernels are pre-built functions that are very optimized for one particular task, for one particular GPU. That's what I meant to say. And Tornado somehow wants to use them, right? For example, I can give you. So in this very first version, the interaction with Llama, we did the Java matrix vector multiply in Java. And we offload it, as we mentioned, with that parallel notation, done easy. That's a very easy process. And we get nice speed up. Okay, we get speed ups compared to baseline. But we can go further. Matrix multiply or matrix vector, those linear algebra operations are very, very well optimized by companies. For example, if you target Intel architectures, Intel gives you the library called 1MKL. And that's a very well-known library for linear algebra. And this type of operations will fly in these devices. Same as CUDA with NVIDIA with 1DNN or cuBLAS or these libraries, right? So the way we see Tornado evolving is to interact, to have a mode in which we call hybrid mode, in which you can, for some tasks or for some methods, you can provide the Java code, and for others, you can just reuse what is around, right? But still, you don't mess around with any GNI code or any Panama code, anything at all. It's just Java. It's just a Tornado library. That's all.
So Tornado is a facade to AI stuff.
Yeah.
A smart one. And over time, you can, revise your decision. You can say this part is now pure Java, and the other one is still calling via Panama because of your expertise, right? So this would be like a facade, a smart facade to AI, right, for Java developers.
Yeah, the user doesn't know that it's using anything else apart from Java. If that makes sense. It's actually Java. The Tornado runtime and compiler will handle this.
So write once, run anywhere, right? Again,
that's
so there's the real one.
That's what I want to achieve.
Yes. Yeah. This is actually extreme good use case, I have to say, right? Because I mean, this is not the future. It will happen in the next 1 to 2 years. I get already more and more questions of what we do with it, how to call it. We cannot call via REST OpenAI, so it has to run locally. How to do it? This how is huge, I would say, right? And you could even go further, because we will need CI/CD pipelines where we can launch Tornado or to test it or to integrate it or to mock it or whatever. So it is actually a huge use case.
Yeah, that's why we were pitching this idea also in Oracle groups, etc., because we need standardized types. For example, I believe that for the Java platform, having tensor operation or tensor types are useful.
What are tensor types? So for Java developers, how to imagine them?
So I'm mapping this tensor concept by PyTorch will do it, Python framework. And basically, if you think about it, this is a list, it's an array of floating point numbers.
Okay.
The thing is, depending on the architecture, that tensor can map to the actual architecture. If you use NVIDIA GPU, they have a type tensor, and it's kind of a matrix type that you can have, let's say, one matrix, small matrix operation, one single operation in hardware, if you like. And that's useful to express other applications from the high level. Think about tensors. I think many people like to think about tensors rather than think about arrays or how to compose arrays to look like tensor. Plus tensor operations like softmax, all of these operations that are attached to.
So you would like to have an tensor type in Java natively, right? Record type, record tensor, or even the value type tensor, whatever it is, or record maybe tensor with value type inside and additional methods for the operations, right?
Yeah, that's open discussion. I don't know exactly the strategy to use.
Yeah.
To me, it looks like Valhalla will help, I think, in this case. Very, really help. Yeah.
And then we have the tensor operations. It already means, could we use the tensor operations to write application, or more or less it will be indirectly used by frameworks like Tornado or Babylon?
The way of thinking is to expose users to this type. So the user already knows the tensor operation.
And how I could use it? So as Java developer, for what? Let's say, because would I write my own model or what with that?
That could be one option. So you are your models and you want to transform from your input, let's say a text file or text string into a tensor representation, and then you send this tensor to the GPU. That could be one thing, like PyTorch does. PyTorch gives you that option. For example, you can convert an image to a tensor, a text string to a tensor, etc. And that's the way I think, or one of the ways.
But if but if PyTorch does that, so if PyTorch has a tensor implementation in Python in memory, and it just reads the text and passes the tensors to the GPU, Python is 35 times slower than plain Java. So if we have this in Java without Tornado, just Java, already this has to be 35 times faster than Python.
I think the argument saying that a 35,000 slow just because the tensor is representing directly into GPU memory, quite likely. So
then they are calling via Gen I to C.
Exactly. Yeah. So to me, a tensor, if you ask me, it should be Panama foreign function memory, off heap data structure to avoid overheads, if that's the question.
So we get something like looks like a Java record or Java class, but actually it is managed by off heap.
Exactly. Yes. That could be one way. I mean, I open for discussion as well to other ways, but that's the way I'm thinking. Yeah.
That is the way which makes sense, because we've had tensors. I don't think it makes sense to have tensors without the intention to run tensor on hardware, right? I mean, because then why?
I don't see the use case.
Exactly. So then we have, maybe we have the tensor, in standard mode without Panama, because we would like just to simulate or whatever, just unit testing or whatever. But usually Panama, the ability to offload it somewhere is interesting, right?
Yeah. So we're thinking to add it in Tornado anyways, but we would like to be this standardized. The user say, I don't have to learn a new API to jump Tornado. I can just have the Java standard API for these type of applications, and Tornado is an implementation of it.
Actually, huge news, right? If you think about this, this is like this is what everyone waits for, because the Python is only popular because of the PyTorch and the other frameworks, because the ability to do so. And if we can do this in Java, I think lots of Java developers will never leave Java to go to Python just to do some machine learning. I would say this. Yeah.
I mean, that's what I totally agree with you. That's what I believe. Maybe I'm wrong, but that's what I believe. So I think many developers use Python already locked into the Python ecosystem. That's perfect. And PyTorch makes total sense. It's a very well-designed framework, very well supported, huge community, etc. Same as TensorFlow. But for the Java developers, sometimes I see developers that jump to PyTorch because they have the need and they go back and forth. With this, we try to not to do that. If you want to stay in Java, you can do it. That's all. We don't want to compete with Python. I don't think that makes sense at all. We try to bring to Java something that is missing from our overview.
Yeah, I mean, competing with Python, who cares? We have to solve a problem. And if we have a Java application, it is easier to remain in Java. I never actually believe in the, how it's called, polyglot programming idea, because in a larger project, having multiple programming languages just for fun or without an obvious reason, I never got the idea. So why to introduce the additional complexity? So for me, the simplest possible project is pure Java, recent version LTS, no dependencies, and let's go, right? So the more programming language dependencies or frameworks we are adding, the worse it gets regarding complexity. It is a chaos at the end. So stay simple. This is the idea. And if you have a Java project, the natural, if you have to integrate with AI, and we will have to because of the marketing pressure and new use cases, we will have to, regardless whether it makes sense or not, it will just happen. Then the Tornado with your startup is the way to go. What's the name of the startup again?
Paravox.
Paravox.
Yes.
Okay.
You touch a point. Can I ask you something? You touch a point saying that this polyglot didn't kind of resonate. Based on your experience in the industry, you think that's common today?
Polyglot?
Yes, having a polyglot application with many.
I reviewed a project. It was like a microservice project, and I found TypeScript, Node.js. So TypeScript, like without Node.js, then Node.js, Go, Python, Java, Spring Boot, and Java Quarkus, and then I forgot, but this was at least this things.
Okay.
And there were like 15 microservices written in this programming languages, and they talk to each other. And then I asked them, how many teams worked on the project and why. And the answer was more or less like, this is microservices, so we thought we can just try things out. But I couldn't. It was really. I mean, the problem was also, we had like maybe 10 different more. At least 10 different Docker super images with various, operating systems. So, I mean, even to keep it secure is mission impossible, because you have to be expert in all the systems. And after I just asked questions, and they immediately recognized that it doesn't make any sense. And at the end of the day, what happened right now is just Quarkus Java without dependencies, and it become boring, but the developers are happy. So I would say it is not very common, and even the microservices are going back. You don't have to have 20 microservices to solve a problem. It's also okay to have a monolith, which does one thing well. And this is what I propagate. If use microservices if you really need them, and if not, just go with a single Java program. Java runs well enough. You get a great performance optimization if there are no remote calls. So I would say the polyglot programming is no more hyped. So it was hyped 15 years ago or 10 years ago, but I never got the idea why. Because if Java is even good enough, I even write command line utilities with Java. I have to parse files, whatever. So if you take a look, I have YouTube shorts, maybe already 500, and of them. And what I do, if I'm bored a little bit, Java app, Java, it runs, and I can parse files, transform files, copy files with 2 lines of code. And before I learn Python or whatever, Java is just good enough, So I would say on an enterprise project, in the larger projects, this polyglot is almost, what can happen is that you have one team, and we really need a team, and the team is expert, let's say, in Rust. So we have to integrate this. There's no way that they will learn Java. But large companies have a huge Java ecosystems there. So I would say 10 years ago, people for fun started to use Groovy or whatever, Scala. But many projects were burned because Scala was not that popular anymore, or is no more that popular. Groovy is also no more that popular as it was before. So in Java 21, and Java gets better and better. Java 21 is great. So really, it's a nice features. So I would say polyglot is not a best practice. Polyglot is a solution to a problem when you are hiring a team and the team is expert in one language. So we can integrate that via remote call, REST, microservice, or whatever. This is my observations in larger companies, right?
That's interesting. So if I can complement that, I'm working with, I told you also in the last podcast, this company that Sednai, that is working with the Gaia mission and doing data analytics, basically trying to create a 3D model of the space or section of the space. And when I talk to them, because they are using Tornado, I say, well, why don't you use CUDA for this section? Well, the problem we have with CUDA is that one person came expert in CUDA came to the company, he wrote the kernel in CUDA, left, no one understand the code, and the rest of the team is Java expertise.
Exactly.
So we try to put everything in Java because we don't want these dependencies forever. And it makes sense because they have a huge code base because they interact a lot with the database to store data, do data analytics, etc., etc. And for them, Java is a must. So yeah, it's kind of aligned with that story.
Yes, and there is because I know Java is not even enough, even Java dependencies, right? So if we take a look in an enterprise project, I see common slang dependency. Nothing against that, but I take a look why it is needed, and often because string is empty or is blank or whatever. And the next question is how often you update the dependency. Because if you forget about that, maybe you're introducing security problem, right? From the and therefore I'm questioning not only programming languages but also Java, all dependencies which Java can have, and I say, okay, what is your strategy with updating this dependency, and do you really need it? Because in Java it's crazy how much we get with Java. Everything is already there, right? So I would say not only polyglot, also focus on Java 21 first. If you cannot find functionality inside Java, then add dependency, right? So this is, and the Tornado for me is a different story, because Tornado is right now almost as like a standard which is running to access GPUs fast. I cannot do this with Java 21. So the Tornado becomes the standard for me. And then I would say I just pick Tornado and not Tornado and let's say PyTorch. It wouldn't make any sense, because if we invest one technology, we set it as standard and just use that. What can happen then, that Babylon becomes, like a not competition, more like the standard way to access Tornado. Then we have to upgrade the project to use Babylon, and Babylon will use Tornado behind the scenes. This is the cycle of software development.
That's how we see also how we interact. Yes, that's the purpose. Yes.
Yeah, and the I give you 20 years. This is actually really interesting exercise to look back what happened at the beginning of Java. At the very beginning, there was no JDBC. This was JDBC was introduced in JDK 1.1, so early, but not from the beginning, as I recall. At the beginning, we talked to Oracle directly. We had no Oracle connection, no JDBC, just the Oracle plain connection. Then JDBC came out. So what we use, we've rewritten the software to use JDBC API, and behind the JDBC API, there was an Oracle connection.
I see. Okay.
Then we got, the Hibernate was first. Everyone was crazy about Hibernate. So Hibernate used the JDBC connection with Oracle connection. So we've wrapped Hibernate with a DAO to make it nicer. But then JPA happened. And, the inventor of Hibernate, Gavin King, said, forget about Hibernate, we have JPA. So what we did, we rewritten all the software, and the software used JPA, which use Hibernate, which use JDBC, and JDBC use, things. And this is how it evolves. And for me, this, the Tornado is Hibernate. JPA could become, Babylon. This JDBC API could be Panama or something like this, right? And we have to or CUDA or whatever you have. And this is the layers. And it's a good thing not to be Tornado dependent, because you not always you need all the features, and you have an independence, even version independence. The cool story is about the added value of the JPA API and JAXers, whatever. We could use JPA, and we got new versions of TopLink back then, or Eclipse Link and Hibernate, without affecting our code at all, because there was the API.
Oh, that's really interesting. Yes. Okay, I take the point, actually.
This is what I do all the time in enterprise projects, and this is why I'm so interested in stuff like yours, because there is no answer how to do it with AI right now. And so I was really interested in what your thought is, and the enterprise companies, they like something more stable. Chasing all the releases, all the craziness is not always appealing. So or never appealing to them, actually.
All right. Okay.
Cool. It was nice to see you, or to speak with you again, and see you as well. And we have to talk more often, especially with your startup. So if you have your first use case, whatever, and I would really interested to talk with you, and what your progress on that front.
Yeah, thank you very much. It was nice to talk to you as usual.
Yeah, send me please all your all your links and show notes, and startup notes. And yeah, it was a nice conversation. Thank you a lot.
Thank you. Bye.